Hello grade 9s, this is Mr. Miller and welcome to lesson 2.4 on determining the square roots of rational numbers. So before we get into the lesson, I just want to go over some perfect squares, make sure that basically you know your times tables. So I'm going to move over to the calculator now and look at some perfect squares. So I'm going to show you a little sort of spreadsheet that I'm starting to set up here. And what you can see here is that I've got some integers, well, positive integers. I'm starting at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then I go to 13, 14, 15, 20, 25, 30, 40, and 50. And so for each one of these numbers, what I'm going to do is I'm going to look at what is the square of that number. I'm going to move to the right and just do a calculation of that. So actually I'm going to go up into L2 here, and I'm actually going to make a formula so it's going to calculate this entire column here as the square of each number in the column to the left. So I'm just going to indicate that that's L1 squared, and now it's going to do all of my perfect squares, starting with 1. And these ones are good for you to know. So just like your times tables, in a way you need to have those known, memorized. It certainly helps you to do calculations more quickly if you know them off by heart. Same thing applies here with perfect squares. And that's because when you get to a higher level of math, you're going to be taking things square roots and simplifying them, and it helps to know those perfect squares. So let's just take a look at the list here. So we've got 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. At this point I'm going to stop and just remind you that when you're squaring a number, just be careful you don't multiply by 2. That's a common mistake that people make. They see the 2 and they think, oh, it's 4 times 2. No, it's not the case. It's 4 times itself. So just like 4 to the power of 3 would be 4 times 4 times 4. So back to our list here, let's go on to the next one. So 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144. Now, some people might just stop at that, but I like to push it a little bit further because, of course, when you learn your times tables, probably 12 times 12 is as far as you go, but grade 9 math, you should be able to handle a little bit more than that. So let's take a look. 13 squared is 169, 14 squared is 196. Actually, that's not that hard to remember because if you can remember the 169, 196, you just reverse the last 2 digits. 15 squared is 225. So now I skip a few and go on to 20 squared. So 20 squared is not too hard because it's 2 squared and it's 10 squared and multiplied by each other. So 4 times 100, 400. I like to do 25 squared because 25 is a perfect square itself. It's 5 times 5, and now we're doing 25 times 25. That's 625. 30 squared is 900, 40 squared is 1600, 50 squared is 2500. So now you've got a bunch of perfect squares known, and this will help you in doing your exercises here. So let's take a look at what we've got. The instructions here tell us to estimate, then calculate the number that has the given square root. So 4 squared is 16, we know that one. 5 squared is 25. 4.4 squared would be somewhere in between. Now this is a little bit below the halfway point, so you might guess something like 19, let's say. And then you can go to your calculator and you can actually verify this. 4.4 times itself is 19.36. So I use the x squared button, but of course you can just do 4.4 times 4.4. That's easier. Or you could always do 4.4 raised to the power of 2. So a few different ways of doing that on your calculator. But regardless, the actual answer is 19.36. So you can see my estimate was pretty close. I took a look at the fact that 4.4 is a little bit closer to 4 than it is to 5, so I'm expecting that this 4.4 squared should be a little bit closer to 16 than it is to 25. So that's why I was thinking somewhere around 19. And it was pretty close, 19.36. So again, let's go through the same process for the next one. I know that 11 squared is 121 and that 12 squared is 144. So if I were doing 11.7 squared, 11.7 is closer to 12 than it is to 11. So I'm expecting the number should be closer to 144 than to 121. So let's say I were to guess something like 137. And now I can verify this on my calculator. Or actually get the calculated value. And that turns out to be 136.89. So my estimate was actually really close. So moving on to the next one, we get into a little bit more challenging examples because we've got some decimals involved. So if this were 7 squared, that would be 49, but 0.7 squared is not that much more difficult. It's 0.49. 0.8 squared would be 0.64, and so 0.78 squared should be closer to 0.8 squared than it is to 0.7 squared. So you might guess something like 0.6. And if I actually do that, 0.78 squared, I get 0.6084. So not bad as an estimate. So now you can see they give you a little bit of freedom. They say, okay, so you've got the idea, you should be able to fill in all the sets of blanks here to go through that process of estimating and then calculating. So again, if you're looking to figure out 10.3 is the square root of what number, approximately, you would start by looking at that 10 squared is 100 and that 11 squared is 121. So these numbers are on either side of 10.3. And so 10.3 squared should be somewhere in between. It's probably closer to 10 squared than it is to 11 squared. So maybe a guess of something like 100 and let's say 8 should be pretty close. If we actually calculate 10.3 squared, then here's what we get. We get 106.09. So being off by just under 2 is pretty good as an estimate, especially when you're talking a number that's larger than 100. Next, we're going to estimate and calculate the area of each square given its side length. And so really this is pretty much the same exercise. So I'm going to start with 0.5 squared is 0.25 millimeters squared. And that 0.6 squared, that's going to give me 0.36 millimeters squared. And so 0.52 millimeters times itself should be closer to the 0.25 than the 0.36. So maybe something like 0.27 millimeters squared should be an estimate for the area. This is really just asking you to repeat the same thing. An estimate for the area of the square is 0.27 millimeters squared. So 0.52 squared is actually, when we calculate it, 0.2704 millimeters squared. So the area of the square is 0.2704 millimeters squared. Okay, now let's take a look at the next one. So a few more decimals involved in this one. If you're taking 0.08 and you're squaring it, you get, so first of all, 8 times 8 is 64. 0.08 times 0.08 has the 64 in it, but we go from having 2 decimals in each factor. 2 and 2 is 4, so it should be 0.0064 square kilometers. 0.09 squared is going to be 0.0081, and this is kilometers squared. So 0.86 kilometers squared should be a little bit closer to 0.0081 than 0.0064, but probably not much. So let's try something like 0.0070 kilometers squared and see if the area of the square that we've estimated is pretty close to that. So the actual answer, when you calculate it, 0.086 squared is, so it's 0.007396 kilometers squared. So the area of the square is 0.007396 kilometers squared. So lots of practice with estimating and calculating of squares. Let's take a look at the next question here. Next question would like to determine whether each rational number is the product of two equal rational factors, and if so, name them. So this one is a no. Now you might be thinking 0.3 times 0.3, but that gives you 0.09. And on top of that, if you take the square root of 0.9, you get a decimal that goes on forever and doesn't repeat. That's irrational, so this is not a rational number. 1/4, this one is a yes. So it's a yes because 1/4 is a half times 1/2. (25/9), so this is another one that is a yes. So it's 5/3 times 5/3. The next one is also a yes because it's 0.9 times 0.9. And the next one is a no because 1 is a perfect square, 10 is not a perfect square. You notice with the fractions, if you have a perfect square on the top and on the bottom, then it is the product of two equal rational factors. But 1 is a perfect square, but 10 is not a perfect square. So, and again, if you try to take the square root of 1/10, you end up with a decimal that goes on forever, doesn't repeat. This is an irrational number, so it's not the product of two rational factors. 1.44 is a yes, so it's 1.2 times itself. Notice it kind of looks like 144, which is 12 times 12. This one just involves some decimals. 0.0001, this is a yes, it's 0.01 times itself. And this one is a yes, so it's 1/10 times 1/10. So lots of practice there, both with fractions and with decimals. So next, number 4, we're just looking to evaluate some square roots, and this is kind of like, do you know how to use your calculator? So the square root of 256, this one I actually know off by heart, it's 16, but just verifying that on my calculator, the square root, the square root of 256 is 16. This one, 3.61, so this is not one that I know off by heart at the moment. So 3.61, when you take its square root, you get 1.9. And again, it's the number that when you multiply it by itself, it gives you 3.61, which is the number underneath the radical sign. So next we've got 1,225. And when you take the square root of 1,225, you get 35. And last but not least, when you take the square root of 0.0484, you get 0.22. Few more examples here, and then we're all wrapped up for chapter 2. So it says here to calculate side length of each square from its area. So if you're told that the area of a square is 1.21 square centimeters, then the length of each side is going to be the square root of that. So that's 1.1 centimeters in the first case. The next one, the square root of 625 will give you the length of one side, which is 25 meters. And the next one, if you take the square root of 0.09, you get 0.3 millimeters. And if you take the square root of 0.36, you get 0.6 kilometers. Number 6, some more practice with estimating and calculating each square root. So here's an example that's done for you. If you wanted to take the square root of 56 to the nearest hundredth, you know that the square root of 49, that's the perfect square just below 56, is 7. The square root of 64, that's the perfect square just above 56, is 8. So the square root of 56, you can estimate is going to be somewhere in between 7 and 8, probably closer to 7 than to 8. So you might, personally I would have maybe guessed 7.4. 7.48 is the actual one when you calculate to the nearest hundredth. So let's go through that same thought process of looking at what is a perfect square that's just under 83. So that would be 81. The square root of 81 is 9. The square root of the perfect square just above 83, so we're taking a look at the square root of 100, is 10. So the square root of 83, I'm thinking, should be a lot closer to 9 than it should be to 10. So maybe I'm going to estimate that the square root of 83 is going to be approximately 9.1. And when you actually do this on your calculator, taking the square root of 83 gives you an actual answer of 9.11. Now they did ask us to round us to the nearest tenth, so actually my estimate is correct to one decimal place, or to the nearest tenth. Next, 5.6. So I know that the square root of 4 is 2 and that the square root of 9 is 3. So the square root of 5.6 should be somewhere in between, probably closer to 2 than it is to 3. So maybe it's something like 2.2. So that's my estimate. And now getting an actual answer calculated. So the square root of 5.6 is 2 to the nearest hundredth, so 2.37. So I was close but not exactly on. And last one, 0.9, its square root rounded to the nearest thousandth. So if you take a look at the square root of 0.81, that would be 0.9. The square root of 1 is 1, so the square root of 0.91 should be somewhere in between. Now it's probably a little bit closer to 1 than it is to 0.9, so I'm guessing maybe 0.96. A little hard to see that, sorry about that. 96. And let's see. Wow, that's really ugly. Let me just fix that. 0.96. There we go. That's a little bit more legible. Of course, if you're looking at this on your iPhone, you might not notice any difference. That's okay. Anyway, so the square root of 0.91 is actually 0.954, 0.954 when we round to the nearest thousandth, which is 3 decimal places. Okay, and one last example here. We want to find the difference between the square of 9 and the square root of 9. So the square of 9 is 9 squared. The square root of 9 is root 9. And when they say the difference between them in math, difference actually means subtraction. So you could describe the difference in words, but that's not really what we're supposed to be doing here. Difference in math, again, means subtract. So 9 squared is 81. The square root of 9 is 3. And so the difference here is 78. That's it. So now you can start your 8 questions on section 2.4. When you're done that, show me that you've got 2.3 and 2.4 done. You can get your quiz done on 2.3 and 2.4. And after that, you're working on your practice test. When that's done, you do the test for chapter 2. So that's it for the lessons in chapter 2. Thank you for watching this lesson and have a great day.